First of all, I would like to thank our management and our department head who has given permission to take this opportunity for conducting an online event for especially our students who are in our internship mode right now. To say about the guest, Dr. Sivakumar is working as professor in the Department of ECE and he is holding the position of Director R&D in Dhanalakshmi College of Engineering. He has completed his UG degree in Sankara University and PG degree from Anna University in the field of applied electronics. He has received a PhD degree from Sankara University, Kanchipuram. Total 26 years of technical and teaching experience, out of which he has published more than 50 papers in conferences and journals, both at international and national level. He holds 7 book chapters into his account, the field of engineering and research. His field of interest include AI, blockchain technology, digital filter design, CAD algorithms for high-level synthesis, and new logical operator design. Together with that, he has got patents also for his credit. He holds a special YouTube channel where he is posting MATLAB related videos for all our students. So I would like to take this opportunity to first of all thank him for accepted this particular invitation. Sir, if my voice is not clear, Shivkumar sir, I welcome you on behalf of our department and students, sir.
Thank you for your nice introduction, sir. Shall we start there? Can I share my screen?
Yes, sir, please. Sir.
Okay, sir. Good evening, students. Myself, am I audible?
Yes, sir, please go on, sir.
Yes, sir. I hope my screen is visible, right? Sir, my screen is visible. Students, any one of you? My screen is visible?
Yes, sir.
Okay. Myself, Dr.M.Sivakumar, professor in EC department and also director in R&D, Research and Development Cell, and Dhanalakshmi College of Engineering, Tambaram, Chennai. Directly I will go to the your syllabus. Statics and numerical methods. It is integrated with MATLAB software. Here, the first unit consists of testing of hypothesis, and second unit design of experiments, and third unit correlation and regression, and fourth unit is numerical solution to equation. It is all the covered topics and all, and then we can directly go to the what is meant by hypothesis, what is the testing of hypothesis in MATLAB, how it is happen. And the goal is to test whether the data provides enough evidence to reject the new rules of hypothesis. In hypothesis setting, the goal is to evaluate whether there is enough statistical evidence to support or reject a claim about a population parameter. My PPT is visible, sir. Students.
Yes, sir.
Yes, sir.
Okay. Okay. MATLAB provides. How many of you know about MATLAB? I hope my audible. Just mutual um, conversation with your you and me, then only we can able to proceed. So that I am asking again and again, my screen is visible or not. If you go for my screen, MATLAB screen, it is a like hands-on training. If anybody doing with MATLAB online, kindly share your screen also. We can interact with each other. If anybody having. Okay. That MATLAB provides built-in functions for hypothesis testing, and also MATLAB provides tools for hypothesis testing, correlation, regression, and ANOVA. It is all the topics covered in the first unit that is called as testing of hypothesis. Here, the MATLAB provides inbuilt built-in functions for hypothesis testing. Now we are going to analyze with simple experiments to help to do the understanding the concepts, sir. And what is hypothesis testing? Here, hypothesis testing is nothing but a statistical method used to make decision about a population based on sample data. And what is the use of this one? It helps determine whether there is enough evidence to support a specific claim or assumptions. Here there are two types of hypotheses are there. First one is S0, that is null hypothesis, a statement that assumes no effect or no difference. For example, for the new material has the same strength as the old one. The next one, alternative hypothesis, is also called as H1. Here a statement that contradicts the null hypothesis. So, what is the example for this one? The new material has a different strength compared to the old one. Here I am explaining about all with us MATLAB for mechanical engineers. Here it is also useful for mechanical engineering. Why you are going to study this type of topics called hypothesis, correlation, and variance, and what is the design of experiments? Then what are the units we are going to study in this uh, subject? The numerical solution to the equations and what is interpolation, what is differentiations, how we are going to use to solve the real time problems. The goal is to test whether the data provides enough evidence to reject the null hypothesis. Here, MATLAB contains to testing of hypothesis built-in functions like t-test, and ANOVA 1 and car function simplify the statistical analysis. Let us see one by one. Why is it useful for mechanical engineers? The mechanical engineers often deal with testing of materials, testing materials and testing the components or system to ensure performance and safety. And hypothesis testing can help with what are the things we are going to do with this statistical methods. That is the testing of hypothesis. First one is quality control, and second one is material selection. Third one is performance evaluation. Fourth one is failure analysis. Here, what is quality control? Here, ensuring that manufactured parts meet as specifications. For example, tolerance in dimensions, material properties, etc. And the second one is second advantage is material selection, comparing new materials to existing ones to evaluate improvements. And what is the example for this one? Strength, thermal resistance, and all. And finally, we are going to do the performance evaluation, the testing the efficiency of new designs called example for this performance evaluation. We are going to evaluate the energy consumption and vibration reduction and all. And finally, we are the testing of hypothesis useful for failure analysis in identifying whether the variation in test results are significant or just random errors. And now we are going to see one simple example for mechanical engineers. What is the scenario is you want to test if a new type of steel has the same average tensile strength as the current steel being used. This is the formula we are going to discuss with this. What is hypothesis H0? The new steel has the same average tensile strength as the current steel. That's a mu. It's simply represented as mu equal to mu current. H1, and then the new steel has a different average tensile strength. So mu new not equal to mu current. This is a formula we are going to see. And this is the first one. What is the example for testing of hypothesis? The tensile strength data in MPa for current steel. So we're going to see the problem in directly in MATLAB. My MATLAB window is audible. My MATLAB window is visible. The same thing I have copied and pasted in MATLAB editor window. Can see the first one is assumes the tensile strength data for current steel. We are giving the data and also tensile strength for new steel. There are two different one. We have to perform a two sample t state. First one is t test, and the last one comments are the comments are used to display the results. display results, fail to reject the null hypothesis. The new still has similar tensile strength to the current still. And the next one, if else display reject the null hypothesis, the new still has different tensile strength. Yeah. If anybody doing parallel with me, I will copy and paste in chat box. You can also do with the MATLAB online, or if anybody having MATLAB software means you can do in parallel, so that we can interact with each other. Some you share your screen, you show your output. Is it possible? Okay, directly I will run the program. Here, what happened? What is the output we are going to see? It's a still program. What is the display? It shows the p-value. It rejects the null hypothesis. The new cell has different stencil strength. This is output for this testing hypothesis. The first program. The p-value, it determines the p-value is 0.0045. Now we see what is the interpretation. If h0 if h is x equal to 0, the test shows no significant difference. So you continue using the current still. If h equal to 1, the new still has a different tensile strength and further investigation is needed. This is the first example we are going to see in tensile strength data. And this is the display of the snapshot of the output, what you get. And the second one, the important of the first unit topic is the chi-square test. What is the use of this uh, chi-square test in MATLAB? And what it test? Check if the observed frequencies of your data set match the expected frequency. It's an example we are going to see. The dice rolls are fair. Testing whether dice rolls are fair. Each number appears equally often. There are two main scenarios in the chi-square test statistical method. First one is to observe the goodness of fit, to check if observed data matches an expected distribution. And second one is independence of attributes, to test if two categorical variables are independent. First, you are going to see the chi-square static value. What is it shows the chi-square static value and also p-value. If it shows the output snapshot of this one. The die rolls just to see. The next one is a program for finding the chi-square statics method. Okay, now you can see the output of this one is observed frequencies, outcomes of the die roll. Observed the value is 10, 12, 8, 9, 11, 10. And what is the expected frequencies for a fair die? Each outcome is equally likely. It is what's expected by using the formula once bracket 1 comma 6 and some observed by 6. What is it to perform the chi-square goodness of fit test? There is some formula is we are going to discuss. And then what is the display? It shows the display value of chi-square matrix statistics and p-value. If the value greater than 0.05, it displays the reject the null hypothesis. The data does not fit for expected distribution. Otherwise, else it displays fail to reject the null hypothesis. The data fits the expected distribution. Let's see what is the output we are going to get. Here, the c-square value c statics and p value is 0.96257. So it shows the value, it exceeds the limit, exceeds the value, p value 0.05. So it failed to reject the null hypothesis. The data fits the expected distribution. Okay, this is another example for testing of hypothesis. The same thing I am giving as a snapshot of this example. And finally, what are the steps we are going to do with the testing hypothesis, especially for to find the goodness of fit? First step is to find the H naught value. The die is fair, and the second one is observe the data. You can see the program. That's the first thing is observe the frequencies, and second one is expected frequency, and finally we are going to perform the chi-square goodness of fit, and observed data and expected data compute x square by using this formula to find the goodness of fit. That is a testing of hypothesis, and finally we are going to compare critical value for alpha 0.05, df value equal to 5 is 11.07. Since 2.5, after calculation 2.4 greater than 11.07, it's failed to reject H naught. So conclusion, maybe the die is fair. This is a simple example of testing of hypothesis to test the goodness of fit. And second part is previously first part is goodness of fit, and second one is independence of attributes. Let's see independence of attributes. It is a what is the independence of it is what it tests. Previously we discussed about uh, goodness of fit. Now we are going to see chi-square test for independence of attributes. Then what is test? It determines whether two categorical variable are independent. And again, one example called testing if customer preference, example for product type is independent of region. What is the key output we are going to get? The first topic is chi-square statistic. It quantifies the difference between observed and expected frequencies. And the second one is p-value. It determines statistical significance. This is example of the p-value 0.05 means it rejects the H naught, null hypothesis. Let us see the RVP value. That is where example, it is a region versus product preference. Simply we get is a snapshot of the output. Let us see the output in MATLAB. Okay, these were contingency table. It shows the region versus product preference, and rows are regions north south, and columns are product preference A and B. Now the example data 50/30 and 20/40. We need to calculate the expected frequencies under independence assumptions. Row totals, uh, column totals, and grand totals, sum total expected. Row totals and column totals are divided by your grand total. Now compute by using the formula chi-square statics, and also you need to find out the degrees of freedom, and also calculate the p-value. Finally, it shows the output called chi-square static and p-value, and also you need to get the message for it reject or fail to reject the null hypothesis, and the variables are independent or not independent. This is a value, this is a output we need to get. Let's see when you click on run, what is happen, you will see that is what output you are getting. Chi-square statistics is 11.667, the p-value 0.00063. So it reject the null hypothesis, the variable are not dependent. It shows the output as the variables are not dependent. In this way, we are going to test by using the chi-square statistics method. And the next one, this is a unit one summary. I need to go through with all the 5 units, so that all the 5 units, each unit at least I have to give 2 or 3 more example problems. Let us see the summary of the testing of hypothesis unit 1. Applications in mechanical engineering, especially for to find the goodness of fit, testing whether experimental measurements match theoretical predictions. Example, we are seeing verifying material properties follow a known distribution. The second one is independence of attributes, analyzing failure modes to check if the type of failure is independent of operating conditions. The example is testing if machine failures rates are independent of shift timings. Why you are going to test, why you are go with this type of test? This test help engineers validate assumptions, improve processes, and ensure reliable performance in systems. And finally, I'm going to explain with the comparison table of different types of test in hypothesis. That is a testing of hypothesis. There are different types of tests. Are there. First one is a test. What is the purpose of this test? Is compare mean with a population, and when to use. Large samples are n less than 30. What is the inbuilt MATLAB function called Z test to perform the Z test? MATLAB have several inbuilt functions are there. No need to go with some problems and go with the initialization of variables and all. It's a MATLAB inbuilt functions used to test the Z test. Z test function will be able to use. Then second one is a T test. Compare, when what is the purpose of this t test is compare means one or two groups. Previously we discussed with t test. Here we are going to use small samples, n greater than or equal to 30. What is the MATLAB functions we are going to use? T test and t test 2. The third test is f test, compare variance of two groups. It's a when to use variance comparison. It's a MATLAB function is var test 2. The uh, the final one is T-square method. There are two types of methods we discussed previously. Goodness of fit. Check if observed matches expected. When to use frequency data, we are going to use with a manual function called G2CDF and independence test independence of variables, and you are going to use the categorical data. The second um, example we are going to discuss with this test independence of variables. This summary provides an overview of when and how to use these statistical tests in MATLAB for mechanical or engineering applications. Then we are going to go to Unit 2. Students, any doubts till now? Nobody give answer, nobody interact with me. It's a simplest duplication in my point of view. The easy in electronics and communication. I am giving speech, I giving some lecture to you means it's the simplest communication. If you get my uh, PPT, if you get my information, we have to give the outputs. This is called the duplex communication. It's a one way communication. I'm giving the only one way communication. You have to give answer. You have to ask any questions means it's called as duplex communication. It's called as two-way communications. Okay. Let's see. Unit 2. I hope you are seeing my PPT. You are monitoring my screen and all. Okay, Unit 2, design of experiments, that is using MATLAB. Design of experiments is a systematic method to plan, conduct, analyze, and interpret controls, test to evaluate factors influencing an outcome. What is the use of this design of experiments? It helps optimize process and understand relationship between variables. And also MATLAB provides tools for statistical analysis and visualization to implement DOE. Here, there are different types of methods we are going to see. Is one method is ANOVA method. ANOVA means analysis of variance. ANOVA is a statistical method used to compare means of multiple groups to determine if they are significantly different. And purpose. It's a what is the purpose of this ANOVA statistical method? Identify whether the variations in the data are due to experimental factors or random chance. What are the inbuilt functions? MATLAB function is ANOVA 1. It's a one-way ANOVA, and ANOVA 2 is two-way ANOVA. Let's see the example. These are experiment called ANOVA graph. Simple values we are going to see. See, these are screenshot of the editor window and a screenshot of ANOVA table and output window. Let's see the ANOVA graph program. These were ANOVA graph program. It's a data where rows are groups 12, 15, 14, and 18, 19, 17 one group, and 25, 24, 23 is one group. Now we need to plot the ANOVA graph. Let's see the output. What is the output? Now we are getting the output. Is for ANOVA table and giving the source value and what is the difference value. You can see the ANOVA table. Then is a ANOVA graph. Is ANOVA graph. This is a simple example for to plot the ANOVA graph by using this by using this design of experiment statistical method. Now let us see the PowerPoint slide. And previously we discussed with the analysis of variance, and second one is two-way classifications. So what is a two-way classifications? A one-way classification method is that the two-way classification method is used to study the effect of two factors simultaneously and their interaction. Example, evaluating the impact of different fertilizers and watering schedules on crop yield. This is a simple MATLAB program for two-way classifications. It's a simple experiment called by using MATLAB. It's an ANOVA graph. And what is a two-way classification method? Here, two-way ANOVA method we are going to see with the simulated data. It's a four levels of factor A, factor B, factor C, and factor D. It's a factor A is a three levels, and factor three replicates for combinations. The data factor A level one, and all three replicates for each level of factor B. And second data factor A level two, all three replicates for each level of factor B. Similarly for factor A level three, factor A level four, remaining all replicates for each level of factor B. Then see, this is a formula to perform the two-way ANOVA. Now let us see what is the output. Click on the screen. Now we can see the TBL value and analyze statistics are there. Now see, let's see what the happen. What's the happen output. And then third one is a completely randomized design that is called as CRT. The simplest experimental design where treatments are randomly assigned to experimental units and purpose study one factor without accounting for other variables. And what is the example is testing the effect of new drug on patients without considering age or gender. Now we can see with this example, MATLAB example is following this code. This is a CRD method. Here the data from 4 blocks and 3 treatments. We are going to see with this one. There is some errors there. Then let's move another experiments called randomized block design. Here also our type of blocks are created to account for variability in experimental units, and also treatments are randomly assigned with these blocks. What is the purpose of this design of experiment is called as reduce the impact of variability by grouping similar units to the into the blocks. We are going to see with the example testing fertilizers on plots grouped by soil type. This is another example. And the final design of experiment method is Latin square design that is simply called as LSD. It is what is the purpose of this LSD method in design of experiments? Minimize variability in two directions. Example field trials for fertilizers with rows and columns as blocks. It is used when there are two blocking factors. It's a row and column effect. And MATLAB example, the MATLAB doesn't have a building function for Latin square, but you can create custom scripts to analyze it by using the Nova inbuilt functions. This is a summary of the design of experiments unit, second unit. And what are the things we are going to discuss in the second unit? One-way classification, where what is the purpose of this design is compare group based on one factor. What is the key idea is ANOVA for single factor. What is the MATLAB inbuilt function? We are going to use ANOVA one. Two-way classification method design compare groups based on two factors and ANOVA for two factors with and without interactions. We are going to use the MATLAB function ANOVA 2 completely randomized design, study one factor ignoring other variables. And also, what is the key idea is a random assignment of treatments. The same MATLAB function you can use ANOVA one. Randomized block design. The another design method is account for variability in experimental units. That's what is the key idea of this design is blocking to reduce noise, and also we are going to use the MATLAB functions called inbuilt functions class. Another two is a with blocks method. The final method is Latin square method. What is the purpose of by using this method is minimize variability in two blocking directions. That is a Latin square layout, and the MATLAB function not doesn't have the MATLAB inbuilt function, so that we can use MATLAB script, custom MATLAB script. Then we can move with this third unit. What is correlation? What is regression? Why you are going to use this correlation and regression? Now we are going to discuss with correlation and regression using MATLAB. Here, correlation and regression are statistical techniques used to explore relationship between variables. Now let us see what is correlation. What are the different types of correlation? Now, correlation measures the strength and the direction of the relationship between two variables. It is a value between -1 and 1. Here, what is 1? What is 1? -1, what is 0? Positive 1 indicates a perfect positive relationship. -1 indicates a perfect negative relationship. And finally, the zero indicates no linear relationship. What is the type of correlations? Two types of correlations are the Pearson's correlation and Spearman's rank correlation. What is the use of Pearson correlation is to measure the linear relationship between two continuous variables, whereas we are using Spearman's rank correlation measures the monotonic relationship between the two variables. It works for ordinal or nonlinear relationship only. Now we are going to see the correlations program. We need to find out Pearson correlation, also Spearman rank correlation value. You can see the example value, x and y, independent variable and dependent variable. Let's see the screen in MATLAB window. And the example data, you can see the output, what is the output. Example data given, Pearson correlation, and this is a inbuilt function. If you see correlation function, it's a transport to match dimensions. And also we need to find out the display results called Pearson correlation and Spear rank correlation. Let's see the what is the output. Here we are going to see Pearson calculation is 0.7746 and Spearman rank correlation is 0.73786. Similarly, the next example, the next topic is regression. Then what is regression? What is simple linear regression? How we are going to compute? The regression is a method for modeling the relationship between a dependent variable and one or more independent variables. What is the use of this regression? It helps to predict the dependent variable based on based on the values of independent variables. Let us see the simple linear regression. Simple linear regression models the relationship between one independent variable and one dependent variable. What is the equation is y equal to a plus bx. Here, what is y, what is x, what is a, what is b. Here, y is the independent variable, x is the independent variables, and also a is the intercept, and b is the slope. Now, let us see the regression program. In the output of the regression program is it shows the slope, intercept value, that is b value and a value. Finally, it shows the predicted y values. To perform the linear regression using polyfit inbuilt functions. You see regression value is example data, the perform linear regression using polyfit function, and also we need to predict the values y prediction. We need to get the output display in command window, slope b value and intercept a value. Finally, we need to get the predicted y values. Let us see what is the output we are going to get. Now, the output in command window, we are getting the output called slope b values 0.6, intercept value 2.2, predicted y values are 2.8, 3.4, 4.0, 4.6, and 5.2. In this way, we are getting output. We are doing the simple experiments with MATLAB inbuilt functions. And previously, we discussed about simple linear regression. And finally, we are going to discuss with multiple linear regression. This involves more than one independent variables. It's called as predictors to predict a dependent variable by using the equation called y equal to a plus b1 x1 plus b2 x2 plus bp xp etc. Where b1, b2, bp are the coefficients for each independent variable. It's a simple example called to perform the multiple linear regression. Here we are going to check with intercept 0, coefficient for x, coefficient for z, and finally we need to get the predicted y values. Let's see the multiple regression. This is a program for to find the perform multiple linear regression. Here example data, that is the independent variable 1, 2, and also dependent variable is set x, different variable y. What is the first step? To combine x and z into a matrix for multiple predictors, and you need to perform the multiple linear regression in the form of prediction values. Finally, we get the output. Let's see the output. What is the output we are going to get? If click on run, we'll get the output. Intercept value is 0, coefficient value is x, coefficient of 0, predicted value is 2.8, 3.4, 4, 4.6, and 5.2. In this way, we are using the simple programs to perform the multiple linear regression. And the final one is a rank correlation. Rank correlation method is used to evaluate relationship between two variables based on their ranks. First one is that is a original data. The common most type is Spearman's rank correlation, which measures how well the relationship between the two variables can be described using a monotonic function. And this one is the Spearman rank correlation example. Here we need the inbuilt functions called car function, COR correlation function. You see this rank correlation example output. This is example data x and y. We need to calculate by using the correlation function in MATLAB. Let's see what is the output. Here, Spearman rank correlation is 1. It shows the output. Spearman rank correlation value is 1. And the final correlation method is partial and multiple correlation. What is partial correlation? What is multiple correlation? Partial correlation measures the relationship between two variables while controlling for the effects of the other variables. And multiple correlation is it measures the strength of the relationship between one dependent variable and multiple independent variables. This is example data. It is a partial correlation x, y, z. It shows the a simple example for partial correlation between x and y, also controlling for z. Let's see the example. Partial correlation. This is a program by using the inbuilt MATLAB inbuilt function, partial correlation function. We are going to see. Just run the program. But what is the output we are going to get? See, let's see. There is a partial correlation x comma y under the controlling for z. That is a value we are going to see. Is a value. Then next one. What is the summary of these key techniques? Previously we discussed with correlation, regression, and in correlation, three types of correlation: rank correlation, partial correlation, and multiple correlation. What is the correlation? Used to measure the strength and direction of a relationship between variables. Pearson for linear relationship, Spearman for rank-based relationship, and regression model relationship between a dependent variable and one or more independent variables. It used to simple linear regression for one independent variables and multiple linear regression for multiple independent variables. And rank correlations are used to where data are ordinal and focus on the rank of the values. Finally, the Spearman's rank correlation is commonly used for rank correlation. And partial correlation and multiple correlation measures the relationship between two variables, and also multiple correlation is examines the relationship between one dependent variables and multiple independent variables. And simple summary of the statics and numerical methods using MATLAB. There is a unit and unit 3, that is a numerical solution to equations and also testing of hypothesis. In this category, statics, there are two different chapters in your syllabus, that is called as statistical and numerical methods, statics and numerical methods. Here the category statistics. What are the subtopics are available in the chapters? First one is hypothesis testing, and second one is c-square test, and third one is analysis of variance, that is called as ANOVA, and correlation and regression. These are all coming under the category of statistics. Here there are three more categories are available in your syllabus. First one is statistics, second one is numerical method, third one is design of experiments. What are the subtopics we are going to use? What is the purpose of this type of test? First one is statistical method, statistics, hypothesis testing. What is the purpose of this test? Test statistical claims. Example, mean differences and proportions. Here several MATLAB inbuilt functions are used to get the hypothesis testing. T-test, T-test2, G2 GYF, G2 test, and usage of example. We are going to for goodness of fit. And similarly, chi-square test, it is for independence. Test for goodness of fit and independence of attributes. The third one is important one, analysis of variance on our graph. Here we need to compare means across the multiple groups. It may be one way or it may be two way. By using the MATLAB inbuilt functions called multi-compare, ANOVA 1, ANOVA 2. These are the MATLAB inbuilt functions we are using. And coming under the category called statistics, correlation and regression subtopic, we need what is the purpose of this correlation and regression? Assess a relationship between variables, compute the regression models by using the MATLAB inbuilt functions called car function, car coefficient, and regression function. And the second chapter, that is a unit 2, design of experiments using MATLAB. Previously, numerical solutions to equations using MATLAB and along with hypothesis, testing of hypothesis. This table summarizes the design of experiments completely. There are three type of subtopics are there. What is the purpose we are going to use? What are the inbuilt functions and what is the usage and example for? This fourth column shows this usage and example. Here the in the subtopic of design of experiment is first one is CRD, the second one is RD, third one is LSD. CRD means completely randomized design, and the second subtopic is randomized block design (RBD). The third one is Latin square design. Here, first one is completely randomized design is analyze the effects of treatments under randomized setups. These are the inbuilt functions ANOVA 1, ANOVA 2, and multi compare units. Then the second subtopic is the randomized block design, controls variability by blocking and testing treatments ANOVA 2. And third one is Latin square design, control variability by using rows and columns in sequence. Here also there are no inbuilt functions are there, inbuilt MATLAB functions are there. By using ANOVA 2 for custom implementation, also you need to encode row column design manually or by using the ANOVA tools. The fourth unit contains the numerical solution to equations under the category of numerical methods. Here, there are so many subtopics are there. Solutions of equations. We need to solve the algebraic or transcendental equations. Example for finding the roots. For MATLAB inbuilt function is F0, Fsolve, F0 for single root, Fsolve for systems of equations by using the uh, methods to solve algebraic or transcendental equations. The second method, the famous method to compute the methods called the Newton-Raphson methods, iteratively find the root of equations. Here the MATLAB inbuilt function is custom implementations. It requires the derivative computations and also iteration in a loop. The third numerical method is to find the numerical solution to the equations by using the MATLAB is Gauss elimination method. What is the purpose of this Gauss elimination method is solve systems of linear equations. The simple function is len solve. It's a matrix division, nothing but matrix division. Let's say A division B, A division of B for solving A is equal to B, or linear solve, len solve function A comma B. The third one is the advanced method of Gauss elimination method is Gauss Jordan method to find the inverse of a matrix or solve the systems. The inbuilt MATLAB inbuilt function is in function, INP MATLAB inbuilt function. For example, inverse of A, it is used to find the matrix inverse matrix or manual implementations. The last one is for solving the Polish equations in numerical method is eigenvalues and eigenvectors. To compute eigenvalues of a matrix, and by example, we are going to use the power to find the inverse of matrix by using the power method is also coming under the example by using MATLAB. It's a MATLAB inbuilt function is EIG. It's the eigen of A. It gives the eigenvalues and eigenvectors. And the third one is interpolation, differentiation, and integration. It contains a unit 5 table. It summarizes unit 5. It's a first one is interpolation, differentiation, and integration using MATLAB tools. Here, what is the subtopic of interpolation is Newton's forward and backward interpolation. What is the purpose of this interpolation by using this MATLAB is to estimate values between data points. What is the inbuilt function? MATLAB inbuilt function is interp1. That is the inter1, INTER P1. What is the usage or syntax for this one? Interp1, x comma y and x query method for 1D interpolations. What is the spline and linear differentiation? And the second one is a differentiation method, the numerical differentiation. Approximate, it is what is the use of this numerical differentiation is approximate derivatives of a function. What is the inbuilt function? MATLAB inbuilt function is diff and gradient method. And that category is integration. Here in this integration, there are three subtopics are there. First subtopic is a trapezoidal rule. What is the purpose of this trapezoidal rule? Approximate definite integrals using a trapezoidal rule. What is the inbuilt function is a trapezoid. For example, trapezoid of x comma y, it integrates y over x. The second method to find the integration by using the MATLAB Simpson rules method. What is the purpose of the Simpson rules? Approximate definite integrals using parabolic segments and integral adaptive quadrature. No Simpson method, but is used. The MATLAB function is called the integral f comma a comma b for numerical integration. The final one is Gaussian quadrature. What is the purpose of this Gaussian quadrature method is to find the high precision integration using chosen points and weights. It is a MATLAB inbuilt function is quad function and integral function. Quad legacy is a integral f comma a comma b adopts Gaussian quadrature automatically. Let us see the unit 4. Previously, we discussed about till now we have discussed about unit one testing of hypothesis, and second unit is design of experiments, and third unit is correlation and regression. Now we are going to analyze about discuss about unit 4, that is a numerical solution to equations and MATLAB. Then what is the numerical methods are techniques used to find approximate solution to mathematical problems. These methods are essential when exact solutions are difficult or impossible to obtain, such as algebraic and transcendental equations, or systems of linear equations. Here, there are two methods are we discussed. First one is Newton-Raphson method. It is an iterative technique used to find the roots of real value functions. It is used for both algebraic and transcendental equations, which are equations involving unknown raised to a power, or functions like exponential, logarithmic, or trigonometric functions. What is the equation? We are going to find the root of f of x equal to 0. The Raphson formula is given by xn plus 1 and equal to xn minus f of xn divided by f dash of xn, where xn is nothing but the correct approximation. F of xn is the value of the function of xn, and f dash of xn is the derivative of the function at xn. And in simple example, we are going to see for Newton-Raphson iteration method, you need to find out the root. Now we'll see the Newton-Raphson method interaction. Now these are defining the function and its derivative. You need to find the initial guess. You need to give the values. There is a example values f of x square minus 4. Its a root is, it may be plus 2 or minus 2. And what is the derivatives? F dash of x we need to find out. Initial guess is x03. Set the maximum number of iterations 10. And what is the tolerance value you need to check. And what is your output we are going to see. Now click run. What will happen? You get, if you click run, you will get the value is root 2. Root 2 is the output to find the Newton-Raphson method to finding the root. Okay, the same thing you got. The second one is previous one, the new solution of algebraic and transcendental equations by using Newton-Raphson method. Second one is Gauss elimination method. Gauss elimination method is a systematic approach to solving a system of linear equations. It transforms the system into a upper triangular matrix from which the solution can be found by back substitution. Here, what is the MATLAB code for Gauss elimination? This will solve the system Ax equal to B by using Gauss elimination method. The third one is inverse of matrix Gauss-Jordan method. Here, the Gauss-Jordan method is used to find the inverse of matrix by transforming the matrix into an identity matrix. This is done by using row operations and is often preferred when working with small systems of linear equations. Let's see the example of inverse of a matrix. That's the Gauss-Jordan method. Inverse of matrix, we need to get the inverse of matrix value. But this will compute the inverse of matrix A using the Gauss-Jordan method. Let us see the example. Gauss-Jordan elimination method. So Gauss-Jordan elimination method program. You need to define the augmented matrix for A and B. You need to get the compute the augmented matrix. Gauss elimination process start with the command word, the line word n equal to length of B. You need to make the diagonal element 1 by row scaling, and also you need to eliminate the elements below the pivot, and also find the back substitution. Finally, you get the solution for this Gauss elimination method. Just to click on run, what is the output you get? What is the, get the values inverse by inverse of matrix. Inverse of matrix value is the inverse of Gauss-Jordan method. Gauss-Jordan method, the program is missed one. This is a Gauss-Jordan elimination method. What is the output you are getting? Inverse of matrix we are getting. These values are shown in the value. And the third one is eigenvalues of a matrix by power method. What are the steps we are going to find the eigenvalues of a matrix by power method? First, you start with random vector b0, and the second step is multiply the matrix A by b0 to get the next approximation b1. And third step is normalize the vector and repeat the process until the convergence. And finally, you get the eigenvalues approximately the ratio of successive vector norms. The power method is an interactive technique used to find the largest eigenvalues in magnitude of a matrix, and also it is especially useful for large matrices where other methods may be too computationally expensive. And the fourth one is the eigenvalue method. This is a simple example. This power method is an iterative technique used to find the largest eigenvalue, and also for the large test. Just you see the example for power method. Power method program. You see the output is to find the eigenvalue and eigenvector by using the power method. The same thing we are getting with this example in the screenshot. There is a 0.7071. And summary, what is the summary of this fourth unit is numerical solution to the equations using MATLAB, Newton-Raphson method, Gauss elimination method, Gauss-Jordan method, and power method. These are the methods are foundational tools for solving complex mathematical problems in various scientific and engineering fields. It is a MATLAB is an ideal tool for implementing these methods due to its powerful computational capabilities. Let's just to see the small recap of fourth unit, the methods under numerical solutions to equations using MATLAB, Newton-Raphson method, an interactive method for finding the roots of algebraic and transcendental equations. And second method is Gauss elimination method. It is a systematic method for solving systems of linear equations. And third one is Gauss-Jordan method, a method for finding the inverse of matrix. And the final one is power method. It is also an iterative method to find the largest eigenvalue of a matrix. Is a fourth unit simple summary. And let us see the final unit of this statics and numerical method subject. Unit 5, that is the interpolation, differentiation, and integration using MATLAB. In numerical analysis, interpolation, differentiation, and integration are the key techniques for approximating functions and their derivatives or integrals. Here, MATLAB provides easy to use functions called MATLAB inbuilt functions, which are also essential when dealing with experimental data or complex mathematical models. Now, let us see what is interpolation. What is the use of this interpolation method? Interpolation is a method of estimating values between two known values in a data set. The most common interpolation techniques includes Newton forward and Newton backward interpolation formulas. Let's see what is a interpolation using interpol built-in function. Here we can see the interpolation using the MATLAB. It's a differential one. Another example, here you need to type this program. You will get this output for by using interrupt one built-in function. Similarly, you go with the second type, Newton's forward interpolation formula. What is the formula we are going to compute? There's a Newton forward interpolation formula is P of x equal to y0 plus x minus x0, and delta y0 plus x minus x0 or x minus x1 by 2 complement, and delta square y0. Here, this method is used to when the data points are equally spaced and we want to find an estimate for a value that lies between those points. This formula based on the constructing a polynomial that passes through the given data points. And Newton backward points by using the formula, we can find out the Data points are equally spaced, but the interpolation point is closer to the last data point. This is the difference between Newton forward interpolation formula and Newton's backward interpolation problem. The next topic is numerical differentiation. What is a numerical differentiation is? It refers to the process of approximating the derivative of functions at certain points. Here, when the exact form of function is not known, the numerical methods provide an approximation of the derivative. So that Newton forward and backward differentiation, it's shown in the formula. Similar to interpolation, numerical differentiations can be performed using Newton's forward and Newton's backward differential formulas. In this slide shows the forward difference for the first derivative. Here, the simple example called a differential, it shows the gradient function, numerical differentiation using the gradient function. See the gradient function output. This one. Previously, interpolation function, it shows the interval value. Previous one. Previous example, that is the interpolation. It is the interpolated value, it shows a 6.25. Then go for differential integration. In this differential integration value, you need to give the two more inputs, x and y. Finally, it shows the um, numerical differentiation using the gradient function. This is a gradient function. What is happened when you click the run? Let's see. It's a differential gradient. It shows the gradient value 346 and 689. It's the same thing we are getting in screenshot. That second one is a forward difference derivative. You need to find the forward difference derivative value. It's a forward differential value method. Just you need to type this program. We will get the output for this a forward difference derivative value. And the numerical differentiation by using the formula, we are going to estimate approximate derivative of a function at certain points by using the formula. It's a numerical integration. The third one, previously discussed with interpolation, differentiation. Now we are going to discuss with the last topic of the unit, numerical integration. Numerical integration is used to approximate the integral of a function when the exact solution is difficult or impossible to find. The sense several methods are used to for numerical integration, including the trapezoidal rule, simple Simpson rules, and Gaussian quadrature. These are the three more important rules. Two rules are used to compute numerical integration. What is the trapezoidal rule? Is the results to approximate the integral of a function by dividing the area under the curve into trapezoids rather than rectangles. The formula for approximating the integral is approximately h by 2 fx of 0 plus 2 sigma fx of I and plus f of xn, where x is the width of the each intervals and x0 to x1 is the point of the intervals. Now see the numerical integration by using the trap-z function. Previously discussed what are the MATLAB inbuilt functions are available for to compute uh, numerical integration. We see numerical integration is the values we are giving x and y value. Psi is a variable to find out the trapezoid. Finally, we will get the integral using trapezoid rules. That is a run command. After that, we will getting after run integral using trapezoid rule is the 333.35. The same thing we are getting in the as a screenshot. That is next one is that is a trap rule function, trapezoid rule function. The same thing. And finally, numerical integration with the Simpson rules. Previously, Newton-Raphson rule. The next one is the Simpson rule. This Simpson rules provides a more accurate estimate by approximating the integrand with a quadratic polynomial over a small subintervals by using the formula shows. Here you see the simple example for Sims. Here there is the Sim 6. Here this output for Simpson rule, Sims X. Now see the output. Sims X integral using Simpson rule. We get the 0. 333. The same thing we got. And numerical integration. Another method is third method is 2-point Gaussian quadrature formula. What is the use of this method is more advanced technique used to solve the approximate integrals. The 2-point Gaussian quadrature formula is based on evaluating the function at two carefully chosen points to give you a more accurate result by using the formula. Let us see the simple Gaussian quadrature adapting integration using MATLAB inbuilt integral function. Let us see. You see the program. Say f value and I value given. What is the output you are going to see? Here, integral using adaptive quadrature method, you will get the 333.33 values. These are values you got. And the unit 5 summary. In this unit, having interpolation, differentiation, and integration using MATLAB. It's a unit summary. Interpolation methods. Here there are two formulas are there: Newton's forward and Newton's backward formulas. What is a use? You are used to estimate unknown values between known data points. And the second method is numerical differentiation. It approximates the derivative of a function when the exact derivative is not available. And the third one is a numerical integration methods. It contains trapezoidal rules, Simpson rules, and Gaussian quadrature rules. It approximates the integral of a function when the exact integral is difficult to compute. These numerical techniques are essential for solving complex real-world problems where analytical solutions are hard to find, and MATLAB offers powerful tools to implement them effectively. These are thing I want to uh, we execute for this by using the MATLAB is a most powerful tools to implement them effectively where the analytical solutions are hard to find. You need to check with MATLAB. And the final summary of this unit 5 is of interpolations: Newton forward interpolation, Newton backward interpolation. What is the purpose? What is the formula you are going to use? What is the MATLAB applications for the interpolation method? Interpolation topic. There are two methods are there: Newton forward interpolations and Newton backward interpolations. And the differentiation, there are two types of formulas that we are going to use. The method, forward difference formula method, backward difference formula method. What is the purpose of this differentiation? Forward difference formula is approximate derivative using forward differences, and the second one is a backward difference formula method is approximate derivative using backward differences by using the formula to calculate the difference between successive points, and also compute using backward and difference of data points. And finally, integrations. There are three rules are there: trapezoid rules, Simpson rules, and Gaussian quadrature. By using the formula, what is the purpose we are going to use, and what are the MATLAB applications for this numerical integration? Trapezoid rules used to divide intervals into subintervals, some trapezoid areas. And Simpson rules use h by 3 concept, wait for intervals. Gaussian quadrature is MATLAB quad function or manual computation of weight at points. And the final one, MATLAB inbuilt functions for interpolation, differentiation, and integrations. Method purpose are previously discussed. And also, I wish to conclude my lecture topic. I've expressed my sincere thanks to Dr. V. Mithukumar, professor in my professor mechanical department, Weltech Multitech, Dr. Rangarajan, Dr. Sakunthala Engineering College, Avadi. And also, I express my gratitude to Dr. Pragadish N. Professor Mechanical Department, Rajalakshmi Institute of Technology, Chennai. Thank you, sir. Thank you for giving this opportunity. And also, I would like to express my sincere thanks to my management, our chairman, sir, Dr. V.P. Ramamurthy, um, giving the opportunity to deliver the guest lecture that the topics called statistical and numerical methods, but especially for the mechanical engineer students. I hope you enjoy this lecture. Thank you so much, sir, for giving this opportunity once again. Thank you.
So thank you very much, sir. The students here, they raised a number of times their hands. Anybody have doubts? Okay, sir. Probably Nimisha and other two students they have raised. Sir, I would like to say this 5 minutes covering in 1 hour is a very difficult job. And with your expertise in power electronics, how could you make up this summary on another domain, sir? That is a very tremendous job. I should give you a very heartfelt congratulations to you for making this one happen, because If I am doing it, it will be a very, very difficult job. So, sir, with your expertise in MATLAB, I think sure students would have got some idea about how to go on with the lab cum theory subject in the forthcoming sessions. From January onwards, they are having the theory as well as the laboratory. Sir,
Okay,
with your permission, are you sharing this recorded video in your link, sir?
Yes, sir. Yes, sir. I will provide you, sir. No issues.
So when the
Also,
students are
students,
requesting it,
if the students want to get my lecture PPT also, I will share, sir. No issues.
yes, initially I told SAR is running a separate channel for the education purpose. So anything related to power electronics, related to projects, watch that particular video channels related to education is very, very beneficial. So once again, sir, I congratulate on behalf of our management, our head of the department, Dr. Selvam, and the organizing team here, sir. Mr. Satish from IQC coordinator, and Mr. Karthik, the event coordinator, and especially our class in charge, sir, is the assistant in HOD, Mr. Alexandra Pandi, who has arranged every student to gather
Don't
over
calculate
here.
in slow way.
So it's a wonderful opportunity for us. One more time, we would like to have you, sir.
Yes, sir.
Especially
Sure, sir.
on
This is
problem
my
solving using MATLAB.
okay, sir. This is my channel.
Yes.
If you go to YouTube, this is for our students. If you go to YouTube,
Hey everyone,
you
welcome to my
type
channel. Today we are going to discuss
Dr.M.Sivakumar.
about design of
You will get
LCD.
this playlist, and one of the playlists is especially for also I am having the EC domain, but also I am giving the lectures based on several domain. For example, playlist. If you go for playlist, it's a MATLAB for mechanical engineers. The playlist contains MATLAB for machine learning applications, MATLAB for fuel cell technologies, and also blockchain technology. What are the things we can do with MATLAB? I posted the playlist here, posted the topics here. MATLAB for image processing, electric vehicle design, and also MATLAB for mechanical engineers, renewable energy systems, and the free MATLAB projects, especially for mechanical engineers. Just you go to this channel in this subscription in this description box. What are the things that we discuss in the YouTube? You can download the projects by giving access by me. You can get students kindly subscribe my channel and also make it is useful for your education purpose. Thanks a lot. Thank you. Thank you, sir.
Thank you, sir.
Sir, Sundar, sir, you can conclude the meeting, sir. Students can leave or not. Okay. So students, already we are 9 minutes past the, exactly 10 minutes past the prescribed time. So even though it is late, I thank you also for joining from your home, for making yourself available during 6 to 7. So if some students are left also, no problem. I think most of them got the essence of the program. Okay, sir. Thank you very much, sir. We'll get in touch with you tomorrow morning.
Thank you, sir. Students can leave.
Thank you. Thank you so much, sir. Thank you.
Thank you.
Thank you, Alagosundram, sir. Also, thank you.